Hello everyone, welcome all to Physics with Astronautics. So in this video we will discuss about some basic formula of kinetic theory of gases, that is KTG, which will help you with the exam of IIT JAM, CSIR NET, JEST and so many MSc entrances. So let's begin. So kinetic theory of gases. So first of all, we have to know Boyle's law. What is Boyle's law? So at constant temperature, the pressure is inversely proportional to its volume. That is, pressure is inversely proportional to 1 by V. Pressure is proportional to 1 by V. So we can write that PV is equal to constant. Then comes to Charles' law, which said that at constant pressure, the volume of the gas is directly proportional to the temperature. That is, volume is proportional to temperature, or also we can say that V by T is constant. So from these two laws, we can consider that PV by T is constant. And again we can write PV equal to nkt, where k is the Boltzmann constant and whose value is 1.38 into 10 to the power minus 23 joule per Kelvin, and here this capital N denotes the number of molecules. Then PV equal to small n RT, where R is the universal gas constant whose value is 8.314 joule per mole Kelvin, and this small n denotes the number of moles. Then the compressibility factor, that is represented as Z, which is equal to Pp by nRT. Also that Z value can be represented as volume of real gases divided by volume of ideal gas. So Z is equal to 1 for ideal gases, and it can be positive, negative, or on any other value for real gases. So if the Z value will be positive, then we can consider it as less compressible gas. That is, gas will expand and the force will be repulsive. And if Z will be negative, then this is more compressible gas and the gas will contrast and the force will be attractive. Then comes to the velocity. So first of all, V average. So V average can be written as V1 plus V2 plus V3 up to Vn whole divided by n. Then Vrms, that is the root mean square velocity, that is equal to V1 square plus V2 square plus V3 square and up to Vn square whole divided by n, and root over of this equation. Then come to the pressure, where pressure can be given as Nm by V, V square average by 3. Also we can write this Nm by V as rho. So the pressure can be written as 1 by 3 rho V square, where rho is the density. So the Vrms can be written as root over of 3p by rho from this equation. So our another formula will be the root mean square velocity is root over of 3p by rho, and this is valid for the three-dimensional case. And then E average, that is the average value of energy, can be written as half mv square. Here this is the kinetic energy, and from here we can write that PV is equal to 2 by 3 and E average. Also we know that for 3D case, E average can be written as 3 by 2 kT. So by equating this equation, we can write that the Vrms value will be root over of 3 kT by m and also root over of 3 RT by m. So from the overall formula, we can get that Vrms can be written as root over of 3p by rho. Another formula will be root over of 3 kT by small m, and other formula will be root over of 3 RT by m, and this is for 3D case. Then come to the probability density. Here Dn by n can be the probability density, and for 1D it can be m by 2 pi kt whole to the power 1 by 2 e to the power minus m by 2 kt b square dv. Then for 2D case, this will be m by 2 pi kt e to the power minus m by 2 kt v square 2 pi v dv. And for 3D, we can write it as m by 2 pi kt root over m by 2 pi kt whole to the power 3 by 2 e to the power minus m 2 kt v square 4 pi v square dv. Similarly, probability density for energy and momentum can be calculated using the formula that is E equal to half mv square. We can relate this v value with this equation, and for momentum P equal to mv. Then here is our average velocity. That is, average velocity can be written as root over of 8 kt by pi m and also root over of 8 rt by pi m. Then the most probable velocity can be written as root over of 2 kt by m or root over of 2 rt by caps m. Then the RMS velocity for any dimension, we can write that VRMS can be written as root over of f kt by m, that is equal to root over of f rt by m, and here f denotes the dimension. And here is our average energy, that is n f by 2 kt, which is equal to f by 2 rt. Here n denotes the Avogadro's number and f is the degree of freedom. So from here we can find that Cv will be equal to dE by dt, that is equal to f by 2r. Also we know the Mayer's formula, that it's Cp minus Cv is equal to r. Here r is the real gas constant, and Cp can be written as f by 2 plus 1 whole into r. Also we know that gamma can be represented as Cp by Cv. So by equating this equation, we can find that gamma will be equal to 1 plus 2 by f. Also, another formula for the velocity of sound in gas can be written as root over of gamma p by rho. Then for monoatomic gas in 3D, the degree of freedom is 3. For diatomic gas in 3D, the degree of freedom is 5 at normal temperature and it's 6 at higher temperature due to one vibrational mode. And for triatomic molecule, degree of freedom is 6 per linear case, that is act like a diatomic case, and degree of freedom is 8 for non-linear case. We know that the ideal gas equation can be written as PV equal to nRT, and the real gas equation is written as P plus AN square by B square into B minus NB is equal to nRT. This is the pressure correction and this is the volume correction. Then Boyle's temperature. So this is the temperature after which real gas starts showing the properties of an ideal gas. So the Boyle's temperature can be written as A by RB. Then come to the critical temperature, critical pressure and critical volume. It is based on the liquefaction, and here the Tc value is written as 8A by 27 RB. And by equating this both equation, that is Tb and Tc, we can conclude that Tc is equal to 8 by 27 times Tb. Then the critical pressure can be represented as A by 27B square, and the critical volume can be written as 3B. Let's come to the adiabatic lapse rate, that is dt by dh is equal to minus mg gamma minus 1 by r gamma. This shows that the temperature decreases with height. And now our collision frequency, relaxation time and mean free path. So the collision frequency can be represented as root 2 pi n d square average velocity. Then our relaxation time, that is tau is equal to 1 by f. So it is 1 by root 2 pi n d square velocity average. Then our mean free path, that is lambda is equal to 1 by root 2 pi n d square, that is equal to v by root 2 pi caps n d square, and also is equal to kt by root 2 pi d square p. So these were our some formula of KTG. I hope you all enjoy the session. So for more videos, please do like, share and subscribe. Thank you.